So this video is our main introduction into trigonometry. Trigonometry deals with right triangles and with the ratios that you see in triangles. So we're going to start off by talking about the triangles we've already looked at, which are the 45, 45, 90 and the 30, 60, 90. So on the screen right now, you can see that I have three 45, 45, 90 triangles, and I've used our rules that we already know to put all the side links on them. So the main thing that I want you to take away from this right now, at this moment, is all of these triangles are similar. We know that because they all have the same angle measures, 45, 45, 90. Every single 45, 45, 90 triangle is similar to another one. It never changes. And what you also know is that all of the sides are in the same ratios. The ratios within the triangles are the same as well as across from the triangles. So what I mean by that is looking at, let's say, the legs. The leg and the leg. They're both 4. 4 divided by 4 as a ratio is equal to 1. Look at the next one. 1 and 1. 1 divided by 1 is 1. Say it, you see it again. 2 divided by 2 is 1. Okay? You see the exact same thing no matter which pair that you choose. I just decided to do both legs. So now let's look at 30, 60, 90. So, same thing. All 30, 60, 90 triangles are similar to each other, and we're saying the ratios within the triangles are the same. So I'm going to do let's mark our right angles here, and then our 30 degrees, and we know the other one is 60. So we can do this again with our two legs. The long leg over the short leg, 10 over 5 is equal to 2. You look at the next one, 6 over 3 is equal to 2. And then the last one, 2 divided by 1 is equal to 2. Now, why this is so important is because if we recognize that these ratios are constant in every single 30, 60, 90 triangle, then we can use these ratios to solve for missing side lengths. So on this page, I have an example. So similar triangles always have the same side ratios no matter what the angle measures are. So here, I've gone away from our 45, 45, 90 and our 30, 60, 90 triangles, and I've picked different angle measures. So you'll see that these angle measures are 90, 65, and 25. So what I want you to see is that the ratios are going to be the same. So normally how you would solve this is to go across and do 4.28 over x equals 2 over 1.5. But we're not going to do that. We're going to figure out what the ratio is in this triangle. We're going to do 4.28 divided by 2. So put that into the calculator. You get 2.14. All right, so that means that x divided by 1.5 has to equal 2.14. So multiply both sides times 1.5. 2.14 times 1.5 gives me 3.21. So this side length is 3.21. So it's basically the same thing we've been doing, but this time we're looking at the ratios inside rather than across the triangles. Now, here's the deal. Your calculator knows all of those ratios. Your calculator knows the ratio of the long leg to the short leg in a 30, 60, 90 triangle. So here's an example. 30, 60, 90. So here's 30, here's 60, here's 90. This ratio we already know is 2. So if this is 3, this is 6. Now, you're not going to know this yet, and we're going to talk about this in class on Tuesday, but the calculator buttons that know these ratios are sine, cosine, and tangent. All right, now, take my word for it on this one. We're going to use the button for tangent, and I'll explain that on Tuesday. And we're going to do tangent of 60 degrees. This button tells us what the ratio is of the opposite side of the 60-degree angle, opposite side, over the adjacent side, meaning beside it. The opposite over the adjacent. So if I put tangent 60 into the computer, what should I get? I should get 2. So if you have your calculator handy, put in tangent, T-A-N button, 60, hit enter, and you get 1.73, which is rounded up to be 2. So, as you can see, we're going to start using the calculator to find missing side lengths. So, if on Tuesday you need to have watched this video and you need to be ready to talk about these 3 buttons and how we use them. And that's it. So, sorry this one went a little long, but we should be good to go. So be ready to start talking about these missing side lengths in right triangles.